Okay, now the next method that we are going to add to our blockchain data structure is our proof of work method. And this is a very important method. A proof of work is very essential to blockchain technology, and it is one of the reasons that Bitcoin and many other blockchains are so very secure. So, what is a proof of work? Well, if we take a look at our blockchain, every blockchain is pretty much a list of blocks, right? Every single block has to be created and added to the chain. But we don't want just any block being created and added to the chain, right? We want to make sure that every block that is added to the chain is legitimate and it has the correct transactions and the correct data inside of it. Because if it doesn't have the correct transactions and the correct data, then people could fake how much Bitcoin they have and essentially cause fraud and steal money from other people. So every time that we create a new block, we first have to make sure that it is a legitimate block by mining it through proof of work. So what does a proof of work method actually do? A proof of work method will take in the current block's data and a previous block hash. And from this data that we supply it, it is going to try to generate a specific hash. This specific hash, in our case, is going to be a hash that starts with 4 zeros. So given the current block data and the previous block hash, somehow we have to generate a resulting hash that begins with 4 zeros. So how can we possibly do this? We learned in a previous video that the hash that is generated from SHA-256 is pretty much pseudo-random. So if the resulting hash is pretty much random, how can we generate a hash from our current block that starts with 4 zeros? Really, the only way that we can do this is by trial and error, or by guessing and checking. So we're going to have to run our hash block method many times until we end up getting lucky one time and generate a hash that has 4 zeros at the beginning. Now, you might be thinking that our input to our hash block method, which we will use in here like this, bitcoin.hashblock with these pieces of data passed in and a nonce passed in. You might be thinking, how can we possibly generate multiple different hashes when we are always passing in the same exact data, right? Because we know from a previous video that whenever we pass in a specific piece of data, we are always going to get the same resulting hash generated from that data. So, how can we alter this data in a way that does not change our current block data or the previous block hash, but we still get a resulting hash that has 4 zeros at the beginning of it? And the answer is, we are going to be constantly changing this nonce value. Okay, so I know that might seem a little bit confusing right now, but let me clarify what actually happens in a proof of work by breaking it down a little bit. So essentially, what's going to be happening in our proof of work is we are going to be repeatedly hashing our block until we find the correct hash, which will be any hash that starts with 4 zeros. We will be changing the input to our hash block method by constantly incrementing our nonce value. So the first time that we run our hash block method, we are going to start with a nonce value of 0. Then, if that resulting hash does not have 4 zeros at the beginning of it, we are going to run our hash block function again, except this time we are going to increment our nonce to the value 1. If we do not get the correct hash value again, we're going to make our nonce 2 and try it again. If that doesn't work, we'll make our nonce 3 and try it again. Then we'll make our nonce 4 and try it again. And we will continually run this hash block method until we find a hash that begins with 4 zeros. That is how our proof of work method will function. Now, you might be thinking, how does this proof of work method actually secure the blockchain? And that's a good question. The reason that this proof of work method will secure our blockchain is because in order to generate the correct hash, we are going to have to run our hash block method many, many times, tens of thousands of times or hundreds of thousands of times, and is going to use a lot of computing power and a lot of energy. So if somebody wanted to go back into the blockchain and try and change a block, or try to change some data in that block, perhaps to give themselves more Bitcoin, they would have to do a ton of calculations and use a lot of energy to create the correct hash. So in most cases, going back and trying to recreate an already existing block, or trying to remine an already existing block with your own fake data is not feasible. On top of that, not only does our hash block method take in the current block data, but it also takes in the previous block's hash. This means that all of the blocks in the blockchain are linked together by their data. So if somebody was to try and go back and remine or recreate a block that already exists, they would also have to remine and recreate every single block that comes after the first one they recreated. This would take an incredible amount of calculations and energy, and is just not feasible for a well-developed blockchain. A person would have to go in, recreate a block by using a proof of work, and then recreate every block after that by doing a new proof of work for each block. This is just not feasible for any well-produced blockchain, and this is why blockchain technology is so secure. So to wrap this video up, basically what our proof of work method will do is it will repeatedly hash our previous block hash and our current block data in a nonce until we get an acceptable hash generated that starts with 4 zeros. Phew! Okay, so I realized that was a lot of information, and it all might seem a little bit confusing right now, but don't worry. We are going to be building out this proof of work method in the next video, and then we're going to be testing it with a lot of different types of data. So you will become much more familiar with how it works and how it is securing the blockchain. Cool. I'll see you in the next video.